Right now, as you are watching this, volcanoes are erupting on both sides of the Pacific Ocean at the same time. In Japan, Sakurajima is throwing ash over a bay where roughly 600,000 people live, and this week Japanese authorities raised the alert level at a second volcano, Kupreanof. In Indonesia, Mount Semeru has already erupted more than 1,300 times this year, more than any other volcano in the country. And on July 2nd, officials raised Krakatau, the descendant of the most famous volcano in history, to alert level 3. And in Alaska on American soil, Great Sitkin volcano has now been continuously erupting lava for 5 full years, while a second Alaskan mountain that has never erupted in recorded history is showing signs of magma moving beneath it. Japan, Indonesia, Alaska, all at once. So the question you clicked on is the question we are going to answer. What is actually happening across the Pacific right now? Where is it most dangerous, and could it get worse? No guessing, no dramatizing, just the facts, the science, and the real stakes. Before we get into it, drop a comment right now. Have you ever seen a volcano in person, or lived through Ashfall, Mount St. Helens in 1980, Mount Spur over Anchorage in 1992, a trip to Hawaii or Kagoshima? Tell me where you were and what it was like, because thousands of you have stood closer to this story than you might realize, and I read those comments every single day. If you want to be the first to know every time something major happens geologically, subscribe right now. It is completely free. And let us go for 5,000 likes on this one, so the algorithm actually shows it to people who need to see it. Thank you. Now, let us get into it. On the afternoon of July 7th, 2026, Mount Semeru, the tallest volcano on the Indonesian island of Java, erupted again. The ash column rose 700 meters above the crater, more than 4,300 meters above sea level, and drifted northeast over East Java. The seismographs recorded the event for 95 seconds. 95 seconds. And here is the number that should stop you. According to Indonesia's Center for Volcanology and Geological Hazard Mitigation, the agency known as PVMBG, that was roughly the 1,342nd eruption Semeru has produced in 2026 alone. Not the 1,342nd in its history, the 1,342nd since New Year's Day. That is an average of more than 7 eruptions every single day, week after week, month after month. And Semeru is not even the volcano Indonesian officials are most worried about. Right now, Indonesia has 8 volcanoes in eruption simultaneously. Merapi, Semeru, Krakatau, Lewotobi, Dukono, Ibu, Lewotolak, and Merapi, with 4 of them held at alert level 3. The second highest level on the national scale. To understand why this is normal life in Indonesia and why it still turns deadly, you need to understand what kind of volcanoes these are. Indonesia sits where the Indo-Australian tectonic plate dives beneath the Eurasian plate. As the descending slab sinks, it carries ocean water down with it, and that water lowers the melting point of the rock above, producing magma that is thick, sticky, and loaded with trapped gas. Thick magma does not flow gently out of the ground the way it does in Hawaii. It plugs the throat of the volcano until the pressure wins, and then it explodes. The deadliest product of that explosion is not lava. It is the pyroclastic flow, an avalanche of gas, ash, and rock at several hundred degrees, racing down the mountainside faster than any car could drive on those village roads. On July 2nd of this year, one of Semeru's ash plumes was accompanied by exactly such a flow, which traveled 4 kilometers, or about 2.5 miles, down the Kobokan River drainage. That is why the exclusion zone there is not a neat circle. The public is ordered to stay 5 kilometers from the crater in every direction, but a full 13 kilometers away along that one drainage to the southeast. The mountain has a memory, and so do the hazard maps. But the volcano that explains the human stakes better than any other is on the island of Flores, and its name is Lewotobi Laki-laki. On the night of November 3rd into November 4th, 2024, Lewotobi erupted violently and without mercy. At least 9 people were killed, some reports put the number at 10, and thousands of houses were damaged or destroyed. Entire villages near the mountain emptied out, and according to local officials, most of those residents never moved back. Take a moment to actually picture that. Whole communities that still exist on the map, but not in real life because the mountain above them changed everything in a single night. Then, on July 7th, 2025, says 1 year to the week before the eruption that opened this chapter, Lewotobi produced something far larger. A column of volcanic material rose 18 kilometers into the sky. That is 11 miles, roughly twice the cruising altitude of a commercial airliner, and pyroclastic flows poured 5 kilometers down its slopes. The head of Indonesia's geology agency, Muhammad Wafid, confirmed it was the volcano's tallest column since the deadly 2024 event, and news agencies ranked it among Indonesia's largest eruptions since Merapi in 2010, a disaster that killed 353 people. Flights to and from the resort island of Bali were canceled. Travelers who thought a volcano 500 miles away had nothing to do with their vacation learned otherwise. And right now, in July 2026, Lewotobi is erupting again. Daily gray ash plumes rising as high as 1,500 meters, alert level 3, a 5-kilometer exclusion zone in force, after PVMBG raised the alert on May 12th when its instruments detected deep volcanic earthquakes and the ground itself beginning to inflate. Let those numbers sit for a moment. Now hold this picture of Indonesia in your mind, because a few thousand kilometers to the north, another volcano is erupting beside a city of 500,000 people, and almost nobody is dying. And that contrast is the real story of this video. Stand on the waterfront in Kagoshima, a Japanese city of roughly 600,000 people on the southern island of Kyushu, and you are looking directly at an erupting volcano. Sakurajima sits just across the bay, its summit only about 8 kilometers 5 miles from the city center, and it has been in essentially continuous activity at its Minamidak crater since 1955. Not 1955 as in it last erupted in 1955. 1955 as in it has been erupting on and off every year for 71 years. The Japan Meteorological Agency, the JMA, currently holds Sakurajima at alert level 3 on Japan's 5-level scale, with the public warned to stay 2 kilometers from its 2 active craters. Just this June, explosions on the 8th and the 11th sent ash plumes 400 to 800 meters above the summit and hurled volcanic blocks up to 700 meters from the vent, while the mountain released sulfur dioxide at around 1,400 tons per day. And in April of this year, Sakurajima produced its first major eruption of 2026, an ash plume 3.4 kilometers high, roughly 10 Empire State Buildings stacked on top of one another, that grounded flights at Kagoshima Airport and shut down roads across nearby towns as ash made driving hazardous. Now here is where things get interesting. How many people did that April eruption kill? None. How many did the even larger November 2025 event kill? The one that threw a plume 4.4 kilometers high and ejected rocks nearly 1.2 kilometers from the crater? None. A city of 600,000 lives closer to an erupting volcano than most Americans live to their nearest grocery store, and it functions. The reason is not luck, and it is not gentler geology. Sakurajima is the same kind of explosive subduction zone volcano as the Indonesian mountains we just discussed. The reason is a system. The JMA and the Sakurajima Volcano Research Center track the volcano with GPS sensors and tilt meters that measure crustal deformation, the almost imperceptible swelling of the ground as magma accumulates and pressurizes below. The alert level is not driven by how dramatic the ash cloud looks on camera. It is driven by what the ground itself is doing. After the April eruption, the JMA noted that the event helped ease most of the crustal deformation that had been building. In plain language, the mountain vented its pressure, and the instruments watched it happen in real time. Local governments publish daily ashfall forecasts the way American cities publish pollen counts, telling residents which neighborhoods the plume will drift over before they leave the house. Aviation advisories go out within the hour. Evacuation routes are drilled, signed, and rehearsed. This is a mountain, by the way, with genuine violence in its past. Sakurajima's recorded eruptions go back to the 8th century, and its 2 largest historical eruptions, in 1471 to 1476 and again in 1914, were catastrophic regional events. The 1914 eruption was so large it reshaped the island itself. Nobody in Kagoshima pretends the volcano is tame. What they have done instead is build daily life around the assumption that it is not. Residents check the ash forecast before hanging laundry. Commuters carry umbrellas on clear days because gray rain falls from a blue sky. City crews sweep ash from streets the way northern American cities plow snow, and residents bag it for scheduled collection. It is not heroic, it is procedural, and procedural is exactly what survives contact with a volcano. That is why the alert JMA issued this very week, raising the volcanic island of Kupreanof, south of Kyushu, to level 2, caused no panic at all. It is simply the machine working. Detect early, warn early, restrict access, and let the volcano be a volcano. It is worth pausing here on what that actually represents. Indonesia and Japan sit on the same ring of fire, face the same violent style of eruption, and get radically different outcomes. Not every time, but reliably enough that the pattern is undeniable. The difference is measured in seismometers, building codes, forecasts, and drills, purchased over decades before the ash ever falls. And you might assume that none of this touches the United States. That assumption fails about 26 miles east of a small Alaskan town called Adak, and it fails a second time at 27,900 feet. On Friday, July 10, 2026, the Alaska Volcano Observatory issued its weekly update for Great Sitkin volcano in the central Aleutian Islands. Alert level watch, aviation color code orange, slow eruption of lava continuing within the summit crater. If that sounds routine, it is, and that is what makes it remarkable. This eruption began with a single explosive event in May 2021, followed by lava that started flowing in July 2021 and has never stopped. For 5 consecutive years, an American volcano has been quietly erupting, filling most of its mile-wide summit crater with fresh rock and pushing flows into the valleys below, just 26 miles from the community of Adak. Most Americans have never heard of it, but Great Sitkin is not the Alaskan volcano that has scientists most intrigued right now. That distinction belongs to Mount Kupreanof, a heavily glaciated stratovolcano on the Alaska Peninsula with no known historical eruptions. None. Not one in the entire written record. And yet on June 22, 2026, the Alaska Volcano Observatory issued a formal information statement reporting ongoing volcanic unrest from a magmatic intrusion beneath the mountain, magma on the move, now confirmed by satellite radar that can measure the ground deforming from orbit, along with a small sulfur dioxide plume drifting off the volcano. Kupreanof currently sits at advisory, aviation color code yellow, and here is the cruel compounding factor. There is no real-time monitoring network on Kupreanof at all. The closest functioning seismometer is roughly 17 miles away, attached to a different volcano's network. Scientists are watching a mountain wake-up call through the equivalent of a neighbor's security camera. Alaskans have lived a version of this suspense before. Through 2024 and 2025, Mount Spur, the 11,070-foot volcano just 78 miles from Anchorage, showed earthquakes, ground movement, and heating serious enough that AVO held it at elevated alert for months while an entire metropolitan area checked the daily updates. Then the unrest faded, and on August 20th, 2025, the alert was lowered back to green and normal. No eruption. That is how this science works. Most unrest ends quietly. But Spur's history explains the vigilance because when its crater peak vent erupted in 1953 and again in 1992, it drove ash columns up to 65,000 feet, twice the cruising altitude of a jetliner, and dusted south-central Alaska, including Anchorage, with ashfall. Which brings us to the real reason Alaskan volcanoes matter to every American, whether you live in Anchorage or Atlanta. On December 15, 1989, KLM Flight 867, a nearly new Boeing 747 carrying 231 passengers, descended toward Anchorage and entered what its crew believed was an ordinary dark cloud. It was ash from Redoubt Volcano erupting 150 miles away. Within seconds, all 4 engines flamed out. For roughly 5 minutes, a fully loaded 747 fell in silence, from 27,900 feet down to 13,300 feet, a drop of more than 2 miles, over mountains that rise to 11,000 feet. The crew restarted the engines with only thousands of feet to spare and landed safely, but the ash had melted inside the turbines and rehardened into glass, and repairs cost $80 million, including all 4 engines. According to the U.S. Geological Survey, at least 15 aircraft on North Pacific routes have been damaged by volcanic ash since 1980. Out of roughly 80 such encounters worldwide in that period, and about 100 potentially dangerous volcanoes sit directly beneath those flight paths, some of the busiest cargo and passenger corridors on Earth. And this is not a niche corner of the sky. As far back as the 1990s, the USGS estimated that more than 10,000 passengers and millions of dollars in cargo crossed the North Pacific every single day, with traffic growing year over year, and Anchorage has since become one of the busiest cargo airports on the planet precisely because it sits on the Great Circle routes between North America and Asia. Every one of those flights threads a corridor lined with Aleutian volcanoes. When Great Sitkin's color code reads orange, that single word is doing quiet, continuous work for people who will never know its name. Dispatchers routing freighters full of your packages, pilots briefing alternates, controllers watching plume forecasts. The system has worked so well for so long that, according to the USGS, not one person has ever been killed by a volcanic ash encounter in flight. Not one across hundreds of encounters worldwide. That record is not luck. It is the direct purchased result of what happened to those 231 people over the Talkeetna Mountains in 1989. Think about that. And that raises the question everything else now hinges on. Because when you lay it all out, Japan, Indonesia, Alaska, plus ongoing eruptions this same week at Mayon and Kanlaon in the Philippines, Sheveluch in Russia's Kamchatka, and Kilauea in Hawaii, the natural human instinct is to look for a connection. Is the Ring of Fire waking up? Is something different happening right now? Is this the beginning of some planetary chain reaction? The honest scientific answer is no. And on this one, the data could not be clearer. The Smithsonian Institution's Global Volcanism Program, which has tracked every documented eruption on Earth for decades, reports that at any given moment there are typically 40 to 50 volcanoes in a state of continuing eruption, with roughly 20 actively erupting on any particular day. And that brings us to the single most important number in this whole story, 40. Roughly 40 volcanoes erupting somewhere on Earth right now, and here is the part that matters, that has been true every single week of your entire life. The week you were born, about 40 volcanoes were erupting. The week you graduated, got married, watched the moon landing, or the year 2000 arrive, about 40. When the Smithsonian is asked directly whether volcanic activity has been increasing, its published answer is one word: no. Furthermore, the volcanoes in this story are not talking to each other. Sakurajima, Lewotobi, and Great Sitkin are separated by thousands of miles and sit on entirely different plate boundary segments. An eruption in Indonesia has no mechanism to trigger one in Alaska. Each mountain in this video also has its own long, local, boring backstory. Sakurajima active since 1955, Semeru in near-continuous eruption since 1967, Great Sitkin since 2021. What actually changed is not the planet. It is that you now have satellites, webcams, seismometers, and a phone that shows you all 40 at once, where your grandparents heard about perhaps one eruption a decade. But here is the part the doommongers online consistently get backwards. There is a real hazard in this story. It is just not the one you see in disaster movies. The real danger is not a waking ring of fire. It is specific and local. The villages inside Lewotobi's 5-kilometer zone and Semeru's 13-kilometer drainage corridor. The ash clouds crossing North Pacific flight routes that carry thousands of passengers every day, and the monitoring gaps in mountains like Kupreanof stirring for the first time in recorded history with the nearest seismometer 17 miles away. The scary version of this story is fiction. The real version is a to-do list. So let us be direct about the practical message here, because information without action is just anxiety. First, sign up for the USGS Volcano Notification Service if you live in or travel to the western United States, Alaska, or Hawaii. It is free, and it sends you the same alerts scientists act on. Second, keep 72 hours of supplies at home: water, food, medications, flashlights, a battery radio. Third, add N95 masks and goggles to that kit. Volcanic ash is not smoke, it is pulverized rock and glass, sharp at the microscopic level, and those two items costing less than a restaurant lunch are the difference between breathing it and not. Fourth, make a family communication plan for when phone networks are overloaded, with one out-of-state contact everyone knows to text. Fifth, if you live near a Cascade volcano, learn today whether your home, school, or workplace sits in a mapped lahar zone and know your route to high ground on foot. Sixth, if ash is ever falling where you are, stay indoors, keep it out of engines and electronics, and do not drive. Ash destroys motors and turns roads to grease. Keep photocopies of key documents, identification, insurance, prescriptions, in that same kit, because ashfall and evacuations do not schedule themselves around office hours. And seventh, when you fly across the Pacific, understand that the quiet system of ash advisories protecting your flight was built for exactly the events in this video, and let that be a comfort, not a fear. These things take an afternoon to set up. In a real ashfall or evacuation, they are the difference between getting through the emergency and not getting through it. If you are in Japan, you already know all of this. If you are near Lewotobi or Semeru right now, the priority is simple. Respect the exclusion zones and follow PVMBG's instructions, not rumors. Final thought. The planet has been doing this for 4.5 billion years. The Ring of Fire was forging islands and burying forests long before a single human being watched it happen. And it will continue long after all of us are gone. We cannot stop a volcano and we cannot switch one off. What we can control, what Japan proves is genuinely possible, and what the gap between Kagoshima and Flores measures in human lives, is what we build, monitor, and practice before the mountain makes its move. The eruption is geology. The outcome is a human decision made in advance. That is the thesis of this channel, and this week across the Pacific is the clearest demonstration of it in years. The open questions now. What the magma under Kupreanof does next, whether Lewotobi escalates again the way it did in 2025, and what Kilauea's next fountaining episode brings. We will keep tracking everything as it develops, every alert change, every new reading. So subscribe so you do not miss updates on any of it. And leave that comment below. Have you ever seen a volcano in person or lived through ashfall? Tell me where and what it was like. 5,000 likes on this video. Let us go. See you in the next one. One thing that confuses a lot of people when volcano news breaks is how eruptions are measured, because unlike earthquakes, there is no single famous number attached to them. Volcanologists use the Volcanic Explosivity Index, or VEI, a scale from 0 to 8, based mostly on how much material an eruption ejects and how high the column rises. And like the earthquake magnitude scale, it is logarithmic. Each step up represents roughly 10 times more erupted material than the step below. That is why the words "a volcano erupted" can describe wildly different events. The eruptions Sakurajima produces almost daily, with plumes of 1 to 3 kilometers, sit at the bottom of the scale. Noisy, disruptive, occasionally dangerous up close, but small. Mount St. Helens in 1980 was a VEI 5. Mount Pinatubo in the Philippines in 1991 was a VEI 6, roughly 10 times more material than St. Helens, and it threw so much sulfur into the stratosphere that, according to the U.S. Geological Survey, it measurably cooled global temperatures by about ½ degree Celsius, close to 1 degree Fahrenheit, for over a year. The largest eruption of the entire 20th century was not in Indonesia or Japan. It was Nova Rupta in 1912 in Alaska, a reminder of what the Aleutian Arc is capable of. And the largest explosive eruption so far this century was the 2022 Hunga Tonga event in the South Pacific, whose atmospheric pressure wave was recorded circling the entire globe. That Hunga Tonga blast also demonstrated something scientists had rarely seen at that scale. The pressure wave alone was strong enough to trigger tsunami alerts across the Pacific Basin, an ocean away from the volcano itself. And above VEI 6 and 7, the scale keeps going. A VEI 8 is what people mean when they say supervolcano occur, eruptions so large none has occurred in recorded human history, and it is why the Yellowstone caldera is the most heavily monitored volcanic system in North America, even though, as its own observatory states year after year, it shows no signs of moving toward an eruption. One more essential piece of scale: the deadliest volcanic hazard historically is not the column at all, but the pyroclastic flow at ground level. When Mount Pelée on the Caribbean island of Martinique erupted in 1902, its flows killed nearly 30,000 people in the city of Saint-Pierre within minutes. That is the phenomenon behind every exclusion zone you heard in this video. Here is the practical takeaway. When you see a headline that a volcano erupted, the word alone tells you almost nothing. Column height, alert level, and distance to people tell you nearly everything. An 18-kilometer column over Flores and a 400-meter puff over Kagoshima are both eruptions, and they are separated by a factor of thousands in energy and consequence. Now you know to check the number behind the noun. Another thing that surprises people is just how organized the invisible safety net over the Pacific actually is, because the near disaster of KLM Flight 867 in 1989 did not just scare the aviation world, it rebuilt it. In the aftermath of the Redoubt eruption, the Alaska Volcano Observatory developed the aviation color code, green, yellow, orange, red, that you have heard throughout this video, a system created essentially on the fly during that eruption and later adopted around the world as the standard shorthand for how close a volcano is to threatening aircraft. On top of that, the International Civil Aviation Organization expanded a global network of 9 volcanic ash advisory centers, each responsible for a slice of the planet's airspace. 3 of them cover every volcano in this video. VAAC, Tokyo watches Japan and Kamchatka, VAAC, Darwin watches Indonesia, and VAAC, Anchorage watches the Aleutians and the North Pacific routes. When Sheveluk in Russia pushed ash to 29,000 feet this week, it was VAAC Tokyo that measured the plume, calculated its drift, and issued the advisory that rerouted aircraft, usually before most passengers ever knew there was anything to avoid. The detection toolkit behind those advisories has become remarkable. Alaska alone has more than 50 historically active volcanoes, and the Alaska Volcano Observatory monitors roughly 30 of them in real time, with seismometers placed directly on the mountains, supplemented by satellite imagery, infrasound arrays that hear eruptions below the range of human ears, satellite radar that measures ground swelling from orbit, and even lightning detection, because large ash plumes generate their own lightning storms that can be spotted instantly in any weather. That is exactly how a mountain like Kupreanof, with no sensors of its own, can still be caught inflating. The satellites see the ground move even when no instrument is listening nearby. The honest picture, then, is two-sided. The surveillance net over the Pacific is vastly stronger than it was in 1989, and it works daily. But it still has holes. and the scientists who run it are the first to say so. Every seismometer on a remote Aleutian ridge is a policy decision, one more example of outcomes being chosen years in advance. Finally, since so many of you watching are in the United States, let us talk about the volcano American scientists themselves watch most closely, because it is probably not the one you expect, and its status right now is part of the honest story. On July 10, 2026, the USGS Cascades Volcano Observatory issued its weekly update. Every volcano in the Cascade Range of Oregon and Washington, Mount Baker, Glacier Peak, Mount Rainier, Mount St. Helens, Mount Adams, Mount Hood, and the rest, is at normal aviation color code green. Small earthquakes were detected at St. Helens and Rainier, and on July 7th, a minor debris flow ran down to Homa Creek on Rainier's flank, similar to one the week before and smaller than flows seen in 2023 and 2025. Nothing about that is alarming. It is background behavior for a big glaciated mountain. So why does Mount Rainier sit near the top of USGS hazard rankings anyway? Because Rainier's danger is not primarily eruption, it is ice. The mountain carries more glacier ice than the rest of the Cascade volcanoes combined, and its geologic record shows that massive lahars, volcanic mudflows of melted ice, rock, and debris, have repeatedly swept down its river valleys and reached the lowlands where towns such as Orting and Puyallup stand today, in some past cases without a major eruption to announce them. Tens of thousands of people now live and work on top of those old lahar deposits, which is why Pierce County operates a dedicated lahar warning system in the valleys, and why school children there practice walking quickly to high ground. Notice the shape of this story. It is Japan's story and Indonesia's, transplanted to Washington state. A hazard that cannot be prevented, a window of minutes to act, and a community deciding in advance on calm green status days exactly like today, whether the warning systems, the drills, and the evacuation routes will exist when the mountain finally needs them to. In the USGS National Volcanic Threat Assessment, Rainier ranks among the very highest threat volcanoes in the United States, not because an eruption is expected soon, but because the combination of ice, steep drainages, and downstream population is unmatched anywhere else in the country. The warning window in those valleys is measured in tens of minutes, enough time to walk uphill if you know that you should and where, and that the siren means now. That decision is being made right now, quietly, in budgets and classrooms, which, after everything we have covered, should sound very familiar.